go. What's going on, everybody? The Network Berg here. Hope you've been doing well. Welcome to another live stream. Let me just see what's happening in the chat. Not much. But anyways, I welcome you to the stream, and we're going to be doing some more BGP stuff today. And I also thought I maybe want to talk a bit about the MikroTik certification and see what people are kind of interested in learning and getting to. Before I continue with the video, just again, I want to remind everybody that I do have memberships enabled on the channel. So if you want to support monetarily, you're welcome to, but you don't have to. Everything is free. And I'm going to keep making sure the labs stay that way, or not the labs, like at least the videos. But yeah, let's jump into some labbing and stuff first. I don't want to continue with this Network Berg Stream Lab because there is so much stuff happening here, and I actually feel like I've accomplished everything I wanted on it, and there's a good chance I might just export this lab file the way it is, so that other people might be able to learn something from it. Ooh, that MPLS looks a little bit out of place. But before I do that, there's a bunch of config that I need to bring up in the startup config, and it's going to take me a little bit of work to do that. On a side note, I'm super excited. My son is being born tomorrow at 1 p.m. So that's less than 24 hours, and me and my fiance are super psyched. She's actually just preparing herself in the bedroom, like getting mentally ready, and I've been working on it like the whole day. Like, I'm so excited, really. Anyways, this lab, let's just close this. And we'll start a nice new fresh lab, but before that, let's create a folder, call it TNB Stream Labs. Just a place we can put all the labs that we stream, and let's just throw that into here, TNB Stream Labs, and then any new labs that I create in the stream, I'll just put them in here. So let's add a new lab. Let's call this MikroTik more BGP labs. The author will be me, and I'll just leave the other stuff blank for now. Let me just quickly make sure everything's up. Yes, okay, perfect. I'm just going to add a couple of nodes. I'm just going to try and add MikroTiks because I feel like if I add more images that aren't easily obtainable, it might be an issue for people that actually want to follow along with the labs, and if I do just export the content. So let's just make it MikroTik. Add like, let's just start small-ish, add 6 of them. And this now won't just essentially be a provider network. This will now be more or less internetworking we're going to start looking at, where we want to exchange more routes between different ISPs and internet exchanges and stuff like that. Let's just call this R. Move away from the beta or beta, even though it's nice. I know it can be a bit problematic with some stuff. Let's make the Ethernet ports 12 maybe. I like that as a good number for my routers. And let's just create them. So each of these routers will essentially now, let's say, they are more or less a ISP. So we're not going to have like VPLS and VRFs and stuff that we're going to be spanning through them. Each of them will potentially be their own little ISP, and each of these ISPs have their own networks that they look after, and they want to maybe peer with each other, and they want to give internet and all kinds of stuff like that. But we're going to be looking at that type of BGP now. So let's just make a nice little ring almost, and I'm just going to add my management network as a little cloud here, and then we can just connect all of the routers on, let's make it Ether 10. I like Ether 10. I know on Ether 1 it would pick up everything and I'd get DHCP and stuff like that, but I want to configure everything from scratch quickly. So let's just add all of this to the management. so that I can access these MikroTiks over Winbox and we can start working on them. So we're adding links. And all of them is connected on Ether 10. Just for simplicity's sake, it doesn't have to be like this in the real world. It could be connected quite differently. I want to see, can I quickly add a text? I just want to add that nice little cloud image. Let's see if I do this. Okay, I'm just going to move this quickly. And I'll go into my downloads. And find a cloud. There we go. There's a nice little cloud. Bring you up. Ooh. Now that's not a little cloud anymore, that's a humongous cloud. I think this aspect ratio is pretty good. Put it there. And that could be our little IXP. Let's just call this an IXP. Bring this to the front. And there we go. Now we have a nice IXP. And let's just start this all up. Now for the sake of simplicity, they will all be in this management range of mine, 192.168.74.128. Just so we can get to the routers, and then we'll start doing some direct peering between the links. So let's just add some more text and decide what IP addresses we're going to assign where. So 192.168.74 dot. Let's start from dot. Well, we can start from dot 100. That should be fine. I'll just bold this maybe and give it a different color. And that should be fine. This will actually be on the /24. So let's make router 1 100, router 2 101, router 3, I think you guys get the idea, 102. Duplicate you, bring you to 4 and make you 103. Duplicate some more. Give you the address of 104 and 105. Groovy. Now we know which IPs will be where. Let me just refresh the topology and start configuring. I'll probably just quickly going to do this through PuTTY because it'll feel a bit faster. But I can't. I need to do it through Mac Telnet. Darn it. Alright, let's just find our neighbors. If I can find my neighbors. Let me just log on to router 5 quickly, see what's going on here. Admin blank, no. Print. I've got an idea that I didn't. Oh, please tell me I didn't do that. Let's just quit. Do that. Okay, this is router 5. Let's just quickly set identities and stuff like that as well. System identity set name R5 IP address add address 192.168.74 dot 104/24, and this is on Ether 10. Let's see, can I actually ping out 192.168.74.2? can't ping out. I feel like I might have created the wrong interface here. Can I edit this? Yeah. Ooh. That's unfortunate. I need to quickly stop the routers and just reconnect that bridge, because this is not my management bridge now. This is just a normal bridge. Oof. Unfortunate. So let's add a new management bridge, make it the globe, reconnect the routers quickly. Ether 10, Ether 10. At least it's just 6 routers, so this is super quick. So for the people watching, what MikroTik certs do you currently have? Or are you just busy studying MikroTik right now? It's actually something I've been wondering quite a lot about. Like, what is the, let's say, the average, I don't want to say certification level of the people that watch the channel, but I'd be interested in knowing, like, who's actually looking at the content. Is it people that want to understand BGP, or is it more or less new people that just want to understand what is MikroTik and how to set it up, how it all works? Now I should be able to actually do something. If I look at my neighbors, I should start getting some. Just do an admin blank, quickly see, is my IP still there? Let's see, can I ping 192.168.74.2? I can, so I should be able to pick up some neighbors. There we go, there's R5. Let's quickly add all of the IPs through PuTTY. Well, we could do it through Winbox as well. I don't really need to enable Ramon since I'm directly connected to all of the routers now. So I'm not going to do that for this video. Even though I always recommend adding Ramon, but since we're acting like this is a bunch of different ISPs, let's not add Ramon. Okay, so I'm thinking this should be router 1. And I can just verify that by going to this interface quickly, look at the Ether 10, and you are 10009. Yes. So let's just add the identity. You are 1. And let's add your IP address. 192.168.74.100/24. Add you to Ether 10 and apply that. And we'll go on and do all of the other routers. So that's router 1. Router 2, you should be this one. So the way I'm seeing this is when I created the nodes, this virtual MAC address is basically telling me which device is which. Since the 02 would be the second node that's created, so that should be the router 2. But let's just connect and confirm. So if I go to my Ether 10, I can see there's the MAC address still. And if I do my system identity, let's just set this as R2, add my IP address. So my IP will be 192.168.74.101/24 on Ether 10. Let's quickly see, can I ping 192.168.74.100? I can. Okay, awesome. Let's add the rest. So router 3, let's quickly do you. No, thank you. I'm going to go into my IP addresses. I'm going to add an address 192.168.74.102/24 on Ether 10. Let's apply you. Can close. So router 4 and 6 are the only ones. I'll just quickly do them through the PuTTY. Admin blank, no. IP address, add address equals 192.168.74.103/24 on Ether 10. and system identity set name R4, and we can close that, open up the next, admin blank, no, system identity set name equals R6, IP address add address equals 192.168.74.105 seems about right. On Ether 10, let's ping out 192.168.74.104, 103, 102, 101, 100. So I can get to all of the routers, which means we can actually start setting up some BGP config as well. Let me close that. Let's just decide what the ASs will be for each of these nodes. So I'll just add some more shapes quickly. Maybe make them a nice rounded square. Give them a dash. Small border width. And I might change the colors in a bit, but it's not too necessary. This is just a preferential thing now. Let's save that. And I'll just make the transparency on. So we can decide which AS is where. Now that I see it, I actually want to turn the transparency back on and change this to a solid. There we go. That feels better to me now. Let's duplicate. Bunch of duplication will happen now. So just duplicate, duplicate. Decide which AS is where. Let's do that. And let's do that. Awesome. Bunch of routers with little plots. And I might just duplicate this text quickly. Let's make this AS 65000. And I'll just maybe change the AS color. Purple looks good. I'll make that router 1. Let's make router 2 AS 65001. Make router, what's that, router 4? No, make router 3, 2, it doesn't really matter. Actually, let's shake it up a little bit. So router 4, we can make 65111. Router 6, let's make that 556. I don't even know if that's actually correct. We'll see in a sec. And then router 5, I'll make like something basic again. So maybe like 65108. Alright. Now let's quickly configure the BGP. So let's start on router 6 because I just want to check it. Is that actually a good value or not? One of the routers I didn't change the name on, that looks like R3. I'll do that in a seckie. So router 6, let's connect onto you, sir. And let's see, what are you doing? Let's go into your routing. We'll go into your BGP. I could use the default instance, but I'm just going to create a new instance. So I might call this my AS. What did we make that? 65556. 56. Let's see if it takes. Now it's complaining about the router ID, but the router ID I'll just make what my public address is, 192.168, which is not really a public address, as you guys know. Oh, I'm sorry. Is the music very loud? I got a new headphones, and it's been kind of like causing issues, I think. Tell me if that's better. But thank you for the feedback. I appreciate that so much. That should be a lot better for you, I think. Anyways, let's continue and add the router ID here. 105. I'm not going to do any redistribution, and I'll just apply this. Sorry, thanks guys. Thanks for bringing it up. Like I said, it's new headset. A friend dropped it off, and usually I would just like tune on the side. There's like this thing you could tune, but this headset doesn't have that. So I turned it down in the headset somewhere in, well, actually in Windows settings here with the mixer, but it didn't clearly take effect. Alright, let's go on. Router ID. We can leave that on. Actually, I might just turn the client-to-client reflection off, and I'll just apply that. So we have this little AS65556, and we will add peers in a sec. Let's just configure the AS on all of the other routers quickly. Router 6 is done. Let's do router 3 quickly, since I need to update that identity anyways. So let's check here. Admin blank, system identity set name R3, and this is 65002. So routing BGP instance add. Our name is AS65002. Our AS will be 65002, and our RID or our router ID will be 192.168.74.102. Cool. Now we can do the same on the other ones. So router 5, let's see here, IP address, let's just print this. Routing BGP instance add name 65108. So let's just call it AS65108. The AS will actually be 65108, and our router ID will be 192.168.74.104. So 6, 3, and 5 are done. So let's just do some more through the Winbox. So let me connect on Winbox. Let's connect onto 1. Go into routing, go into BGP, add an instance, call it AS65000. 65000 is the actual AS. Router ID 192.168.74.100. Oh, I didn't disable the client-to-client reflection on the other routers. I'll do that in a bit after I add the peers for them as well, because this won't do anything until we actually have the peers also configured. So router 1, router 2, routing BGP instance add AS 65001 001, and then 192.168.74.101. Disable that. And then I think router 4 was the only other router I still had left. Let's just see. Router 4. Let's get on here. There we go. Add another instance, AS. This is 65111. 65111. Router ID 192.168.74. Let's just check on the IP here. 103. And disable this. There we go. So let's just start with some basic peering first. Let's get router 1 and router 2 talking. Let's get that BGP peer up between these two ISPs. Let's maybe just give them some names as well, so that people, well, not people, even I understand if I'm talking about ISP1, what am I actually talking about? Is it ISP1? So let's just call this ISP1. Duplicate that. Make you ISP2. Duplicate. ISP3. Oh, that should be ISP3. That one should be 4. Good. Would have been pretty bad if it duplicated everything there. ISP5. Let's do an ISP6. There we go. Now let's just continue with the peering. So ISP 1 and 2, we'll get them peering now. But this is through the IXP now. This isn't like a direct peer. Direct peering, it's kind of the same if you think about it. It's also just a cable, but directly between the service providers. So they might have a neutral data center where they both have a presence, and then they would just, we would call it an interconnect, or a, some people might call it a cross connect, just to get between the two provider or ISP networks, so that you have a direct connection. You might also see this for people wanting to, you might hear that we want to interconnect with Google or Netflix or something, so that you can have better services to their services. A good example is again Netflix, because this is a very bandwidth intense application, lots of streaming. So if you're an ISP, it makes a lot of sense for you to just take a cable, and let's say ISP1 and let's say ISP2 was Netflix, but it's not really. But you connect that cable directly to Netflix and you peer straight with them. You could potentially like free up a lot of bandwidth for your actual internet services, because it doesn't need to go through the IXP. It can go straight to Netflix, so that you're streaming bandwidth through your interconnect with them instead of your normal like user internet, so that you don't get people complaining, hey, our internet is slow, and you're looking at the torches and you're like, oh no, my 1 gig link is being capped out by people watching Netflix. So this is a good way to fix that potentially. Alright, going off a tangent, let's configure this BGP. Do I have ISP1 open or router 1? There we go. So let's just add the peer quickly. So BGP peers. So this is very straightforward right now. We do want to put stuff on like filters, but we'll get to it as soon as we've started forming the peers. Now let's just call this peer to ISP2. And we'll make this the AS65000. And the remote address will now be ISP2's public address, 192.168.74.101. The remote AS is 65001. I'm not going to change anything with the next hop choice. It's very rare for you to change stuff there, to be honest. This won't be multi-hop because it is on the same network, essentially. We're not doing any route reflecting. We can leave the other values default, hold timer 180, TTL 255. In and out filter, we might want to put in like a filter that says ISP2 in and then ISP2 out. Again, the filters are basically a place that you can specify what routes you are permitting to leave out of your network, as well as what routes you're allowing to come into your network. So this is where you can make a lot of cool tuning and changes on various things. Like you can change things, think of it like a preference on which route is better, which route isn't better, and you might, maybe you've got extra routes sitting on your network that you don't want ISP2 to learn about. So this is why you want to out filter, just so that you can stop those routes from being sent out. We're not going to set it on passive. We're not doing default originate because we don't want to tell ISP to, if you want to get to the internet, come to me. It's going to be a lot of bandwidth we waste. Okay, let's apply. Very straightforward. You see, I'm not even doing anything on advanced. It's just a plain IP family, and this is it. I could set the update source. We could potentially just make that Ether 10 just to force that, but it's not going to have the big ramifications if we don't. It should just actually automatically choose that. Alright, let's go to ISP2. And ISP2, I'll just quickly run through the command line to get this done. So I'm going to jump onto PuTTY, and I'm going to go admin blank IP address print. I don't want to print IPs. Routing BGP. Let's just export this so we know, okay, this is 65001. Now what we're going to do is we're going to do routing BGP peer. We're going to add a peer, and we're just going to call this ISP1 peer. We can set the remote AS as 65000, and we can set the remote address as 192.168.74.100. We need to specify the instance, because we created a different instance called AS65001, which I'll do here. And let's just see, is there anything else we want to set? Very straightforward so far. Let's just set the update source as well as Ether 10. Let's do an in filter and an out filter so long. So let's just call this ISP1 in, and the out filter is ISP2 or ISP1 out. Sorry about that. And hit good old enter. So if I do a routing BGP peer print, I can see my peer is actually established, so that means it is working. I am peering with ISP2 now, or ISP1 from ISP2. And if I do a routing BGP peer print status, that'll just give us a lot more detail on what's happening. So we can see all the filters and all of the extra config and all that good stuff. So let's do a routing BGP peer BGP advertisements. Let's print that. What do I see? I see absolutely nothing. And can anybody guess why I see absolutely nothing? The reason is I haven't specified any routes that I want to send out from either ISP yet. So there's a few ways we can do that. The simplest and easiest way is just to go on to, let's say, router 2, and then from router 2 I'm going to do routing BGP network, and then from here I can add networks that I want to advertise out. So let's add a few networks, but we first want to figure out what do we want to advertise. If it is on an ISP level, we're typically not going to be advertising private IPs unless it's direct peering and you guys have an agreement on what private IPs you can leak to each other. But typically you would just be learning each other's public ranges. Now let's assign some public IP ranges. So I'm just going to use the, let's say, DHCP no address found IP. And I'm sure you guys have seen me use this IP before, because it kind of looks like a public IP and it is an experimental IP, but it's better than hijacking some, well, not hijacking, but using somebody's actual public IP. There's a few things we could actually make it. Actually, let's close that and let's make it something like on my previous lab I used 999.1 as router ID or whatever. So let's use stuff in that range, because that is typically also not used, or it's used, but it's not for us to use. So it's not like you're going to advertise that on the internet. So let's do 999.0/24. That will be ISP1's public range. And then we can do 99910.0/24 is ISP2's public range. So this is their public address pool. They've applied for those IPs from their respective registration guys, and they were like, here, you can have this IP pool, do with them what you want, assign them to servers, or give them to customers, or whatnot. Now let's just go back onto router 2, and let's add this 9.9, oh, we need to just say network again, 9.9.9.10.0/24 network. I'm not going to put on anything else, we don't need to. You could do synchronize, but it's not going to do anything really. So let's just add this, and if I jump onto router 1, are we going to see anything there? I think I've got Winbox open here for router 1. There's router 1, there's up here. So let's go look at our... I also learned we could do this potentially, but I hate how it makes the font look, but at least it makes the wording a bit bigger. So let's see, in my advertisements, am I learning anything? I'm not learning anything. So why is that? I think it is potentially because on router 2 I do not have, like Benoff said earlier, I don't have that IP address assigned. So let's quickly just assign that. Let's just create a bridge IP address add, or not address, let's just do a interface bridge add. Give it a name as LO0 IP address. Let's add the IP address of 9.9.9.10.1/24 to the bridge. And if I jump back to my router, I might have to just resend or reconnect the peer. So let's just force that by disabling it, re-enabling it. And let's check, do we learn anything? Let's look at our IP routes. I am actually learning the route. Interesting that I don't see anything in the advertisements here, because I should actually see it there. Oh, hang on. No, but this still doesn't do anything, and all should show something. Let me jump onto the terminal quickly, and let's see. Yeah, that's correct enough. So let's ping 192.1, no, 9.9.9.10.1, so I can ping it. Just want to see routing, BGP, advertisements, prints. Why don't I see it there? It's pretty strange. I should actually see it there if I'm learning the route, because if I go into my routing table, and if I double click on the route, it gives me all of the information, and I can see which AS I learned it from. This is definitely not an IGP. I wonder if this virtual lab is causing some issues. Hey Stefan. Anyways, let's just assign some more IPs. Let's just do the same on router 1 quickly so that router 2 can learn some addresses. So let's add a bridge. No ports, we're just adding a bridge. And this can be LO0, apply U. Go into our IP addresses, add the address 999.1/24 on Ether, not Ether 10, LO0. And let's just advertise this route out as well. And routing BGP networks, add it 9990/24, apply that. And let's just resend and refresh, and let's jump onto router 2, which we have a PuTTY session open to. Let's just do an IP route print. So I am learning the route from ISP1, and I ping 9991. I can. Perfect. Routing BGP advertisements print. Now I'm seeing something. but this is on router 2. Print detail. Detail. Why does it not allow me to use the detail function? It shouldn't be anything like that. Print. Brief. Oh, hang on. ISP1 here. Detail. Alright, that works. So we can actually see we're getting route BGP advert from ISP1. We can see what the prefix is we're getting, what the next hop is, and what the origin is. Okay. So that is one route that we're learning. Let's add a few more. And I'm not going to just add BGP to everything now, or I will get there, but let's just make this more interesting. Because maybe we have more than just one public range. Maybe we have multiple. And we're going to do the example of where we're going to limit what ISP2 receives from me. So let's try and keep it simple. So 999.0, let's make it 10 and 11. More IPs, and them I can also just assign to the bridge actually. It shouldn't cause any issue. Potentially. So let's jump onto the bridge, or router 1, and let's just add these IPs quickly. So this was 9.10.9.1/24 on the bridge, or LO0. Let's just copy that, make it 11, apply that, and let's add those networks to our BGP. Because we do want to advertise it out, but we're going to do some stuff with the filtering just now. So 9.10.9.0/24, turn off that, apply that, and let's quickly see on router 2. I might just have to refresh the routes, but let's see. Let's do that quickly. So go into my peers, let's resend, refresh. Let's go back there. IPA route or route print. I'm learning the routes. Let's see, ping 9.10.9.1, 9.11.9.1. I can get there. Okay, so let's just paint a little bit of a scenario. Okay, there is routes, but this is on router 1. Okay. So let's just say from router 1, we want to stop router 2 from learning some of our routes. We don't want them to learn about our 9.10.9.0/24 subnet. We want to effectively drop these packets. So let's quickly action that just by adding a filter. And we've already specified a filter in the routing. If I go to the BGP and the peers, and I look, here is a filter called ISP2 in and ISP2 out. So all that we need to do really is go into the routing, go into our filters, add a filter, and think of this as firewall rules for your BGP. So ISP2 out was the chain, and what prefix do we want to actually use? So we could say the prefix is 9.10.9.0. What is the prefix length? Well, it was a /24. And what do we want to do? We can set it to accept or discard, or we can pass through or reject. So I'm just going to set this to be discarded. And let's quickly apply this. And if I go back, I might need to just disable and re-enable this, because there is a little bit of a, let's say, a bug on Router OS, which makes you have to just not redo, but disable, re-enable your filters if you've already have them applied, like I do. So let's quickly see on ISP2, which is router 2. If I do IP route print, I'm already seeing I'm learning one less route. So I'm no longer learning 9.10.9.0/24, because I am dropping that from router 1, from the out filter on router 1. So it's trying to send out that network, but and if I had networks to the other ISPs, like ISP3 for example, ISP3 would still receive those routes, unless I also have a filter to ISP3, which is dropping the traffic, which we might do quickly. So let's just go into router 3 as well and create a peer to router 1 and see what is the result. So routing BGP peer, add name ISP1 peer. Okay, I do have the AS, so that's fine, we can continue. So our instance is AS65002. Our update source will be Ether10. Our remote AS will be 65000. Our remote address will be 192.168.74.100. So we've got instance name, update source. Let's just set some filters quickly. In filter is ISP1 in. Out filter is ISP1 out. Save that. And let's just add the peer on ISP1. So ISP1, add another peer. Call this peer, or let's call it ISP3 peer. Select the right instance. Set the remote address 192.168.74.102. I think this is. That's correct. The AS is 65002. Our other details, we don't need to change anything. Let's just set some in and out filters again. So ISP3 in, ISP3 out. And we don't need to set anything else. Just to get this working, let's apply. Awesome, so that peer is also established. I'm not learning any prefixes from ISP3 yet, obviously. So let's jump back to ISP3, which I have a PuTTY session on. So if I do an IP route print, as you can see, I'm learning 9.10.9.0/24 from ISP1, as I do not have that set to be disabled. This is something I find a bit interesting. 9910, and the next hop is ISP2. BGP advertisement print. I feel like this is something almost as an error on virtualization, specifically on MikroTik. I've seen this because I'm learning the BGP route, but this kind of also applies to real world where people accidentally send out the wrong public address, and then everybody else learns about this wrong public address and how to get there, which comes into BGP route hijacking. It's such a strong term. Most of the time it's done completely by accident. But what's interesting for me is I'm learning 9.9.10.0/24, and I'm learning that the gateway is 192.168.74.101. But The issue that I have is I do not have a peer configured to 192.168.74.101. So I actually want to jump onto Winbox and do a little bit of troubleshooting. I want to figure out why is that? Why do we learn that route? Because I typically should not be seeing that route. So let's get to router 3 on Winbox, and let's just see here. If I go to my IP routes, I click that. So it is actually okay. It is learning it, but I don't know why it's learning it as IGP. Because that feels definitely wrong. This should be EGP. Alright, but this is just like the BGP path. It's learning the path from, because it knows that this BGP for ISP2 connects to ISP1, and it's sending the routes to ISP1, but the ISP1 is also kind of just sending that route to ISP3, which in essence shouldn't have anything to do with ISP3 at this point. So we could also maybe just fix that by adding some more route filters, which we've already added. So let's say on the routing filters, and if I look at my routing here, I've got an ISP1 in. So on ISP1 in, let's just call this ISP1 in, I already know that 9.9.10.0/24 I should be discarding when I'm learning that from ISP1. So let's apply that, and let's just quickly create a peer to ISP2 as well. So ISP2 peer, give it the same instance, remote address 192.168.74.101, 65001. Give it some filters quickly, ISP2 in, ISP2 out, apply, and let's jump to the ISP2 router. Add that peer quickly, so routing, BGP peer, add name, ISP3 peer, AS, no, we're not doing AS override, we're doing remote AS is 65002, remote address is 192.168.74.102, the instance is AS65001, our update source is Ether 10, our in filter is ISP3 in, our out filter is ISP3 out. Alrighty, routing BGP peer print. So now I have peers to ISP1 and ISP3 from ISP2. So these three are technically not, so they're not all kind of like just peering directly with each other. Well, each of them have a peer to each other, if that makes sense. So ISP1 is connecting to ISP2 and 3, and vice versa, ISP3 to ISP1 and 2, and 2 is connecting to 1 and 3. Alright, now let's just quickly jump back on the routing table for ISP3, and I just want to have a look at my IP route print. Now I'm learning the routes for ISP1 through ISP2. So maybe we want to drop that as well. But it's not always the case where you just want to drop everything, because if this is true BGP and it is following the path, there is almost like a form of redundancy, because the routers aren't just all like in this type of hub and spoke type of connection. In the real world, I think I've shown a picture in a previous stream of the internet, like routers are more or less, there's another router here and here and here and here, and they follow like this long path, and they all are connected in this big old cobweb almost, which is pretty cool. But yeah, so it might also be unwise to just drop any routes you learn, but just for our demonstration and what we're trying to achieve, we will be dropping some routes. So on router 3, I do not want to learn ISP1's routes from ISP2. So let's just quickly add some route filters for that. And we can do that from the CLI on router 3. And here we can already see which routes we want to drop. It's the 9990/24 and 91190. So let's quickly set them to be dropped. So I'll do a routing filter add. Then our prefix will be 9990. Our we need to set the chain as well. So that was ISP2. Let's say in. So this is an in filter now. And we want to also just set the action as discard. And there's one thing that I am forgetting. Well, it's not really forgetting, it's the prefix length. So this was a /24. So for the IP route print, I'm now dropping that one route that I'm learning from ISP2. So let's do this other route, and let's just try a different way quickly. So routing filter add, then our chain is ISP2 in, our prefix is now going to be 9.11.9.0/24, just like that. I'm not even going to do prefix length now. I'm just going to set that as the prefix, because I know that is the prefix. And we can set the action to discard, and it should just be that simple. So let's do an IP route print. And now I'm dropping the 9.11.9.0/24 route from ISP2. So ISP2 is no longer sending me ISP1's route. This is like really weird to me that this happens on... I don't know why Eve is... I don't want to say it's Eve. It's something with the virtualization. Like it's seeing it as IGP, and it really shouldn't, because we aren't connecting on the same AS. Though I might play around with the router 7 BGP as well, because I know there it shows us eBGP. Anyways, we're learning ISP1's routes and ISP2's routes correctly at ISP3. We just want to fix some of the routing on the other routers. So let's jump back to ISP2. Let's look at our IP route print, because now I have the similar issue of I am learning some double routes now. And the gateways are correct, but I shouldn't be like learning. If I look at the IP route print detail and I see route 1, I can see the BGP path it's taking, what the origin is, and where it's receiving the route from. So let us just add a in filter on ISP2 on the peer that's connecting to ISP3. Let's look at the IP route print. So all we're going to do is, it's pretty basic to see which routes it is. It's these ones that aren't currently active. So we could just do a routing BGP, routing filter add chain ISP3 in, prefix equals 9990/24, and our action is discard. And we'll do the same for 9.11.9. And if I do an IP route print, that already looks better. And let's look at our routing BGP here. Print routing filter. Let's just look at what filters we have. We've got filters now to ISP3, and this is just in filters. Let's just add some more filters quickly. So let's do a routing filter add chain ISP3 out, and to ISP3 out I only want to send them my prefix of 9.9.10.0/24, and that I will accept. I could also pass through potentially. And I'll do the same for my ISP1 out filter. And then the other thing I'll do is I won't specify any prefixes, and anything else I'm just going to discard. That's to ISP3, and this will be to ISP1. So this way I've kind of set it up that only the routes that I specify on the route filters will get sent out, instead of like BGP just sending all of that route information out to the other routers. Alright, I want to do the similar thing on router 3 and our router 1, which I'll do on Winbox now in a second. So let's just do a routing filter export. So routing filter add chain ISP1 out. Our prefix is going to be 99.11.0/24. I just want to confirm. I haven't even set it yet. So let's just set it 99.11.0/24. So that will be our prefix, and our action will be accept, and we'll do the ISP2 one, which will also be accept, and then let's do that almost that default drop action. So anything else I will drop or discard. So that's ISP1 and ISP2. And then last but not least, let's just do ISP1's configuration through Winbox. So router 1, to make you a bit bigger, and let's just go into our routing filters. So there was a specific thing that I was dropping to ISP2, but let's just do ISP2 out. Let's make sure we send all of our other routes still, so 999.0/24. That we will accept, and I'll just copy that 9.11.9.0/24, that will accept, and then the last one will be our basically drop everything else. So let's discard that, and let's do our ISP3 filters quickly. So ISP3 out, and then it will be the same prefixes. I'm not going to drop anything now, it's just going to be 999.0/24. We will accept, copy that, .10.11, and then the last rule will be anything else gets discarded. Alright, that looks pretty good. So now we've got some route filters. So I should be learning the routes in a way that I expected on these 3 ISPs now. So let's go check out router 3, actually router 2 is a good point. So if we do an IP route print, I can see what routes I'm learning. So I'm learning 999.0/24, and I'm learning 9.11.9.0/24 via this ISP. I still need to advertise routes on router 3, so let's just quickly do that by doing a... Did I add the loopback address yet? I'm not sure. Let's just see interface bridge print. I don't have one, so interface bridge add name allo0 IP address add address. Let's make this 9. I think this was... No, this was 9911.1/24. And the interface will be our bridge, or allo0. Now let's just advertise this route out via the BGP. So if I do a routing, let's do this a different way. So instead of me doing the routing BGP network and adding the network here as such, line 9.11.0/24, instead of doing that, let's send this route out actually via redistribution. So we could do something like routing BGP instance. Let's just print it. So we see our instances is 0, which is the default, and 1 is the new instance we created, which is connecting to our peers. So routing BGP instance set. And then you see all of these cool options: redistribute, redistribute connected, redistribute static, redistribute RIP, redistribute this and that. So all this means is if you redistribute connected, any connected routes in the routing table will get sent out, and that route for the 9.9.11.0 is a correct connected route because it's configured on the bridge. So let's do a set redistribute connected and put that as a yes, and we know this is for item 1. Alright, so if I do routing BGP networks print, there's no network I've specified here, but if I go to router 2 and I do a IP route print, there was 4 routes here, 2 of them connected. Now we've got 5 routes, and the additional route we're learning now is 9.9.11.0/24, and that's through router or ISP3's public IP address. So if we do an IP route print detail, we can drill down and see kind of what is happening here. Now we get a BGP incomplete. Awesome. Which is also not awesome. Alright. So our 3 ISPs are now learning each other's public ranges, and they're able to kind of get to each other now. So we maybe want to tweak some stuff. I know this was a question I had last time, but I really think this might fail. So I'm going to add another peer behind ISP1, and we're just going to make it another MikroTik. Keep it simple. We won't do anything majorly impressive. It's just going to be, we're not even going to add more ports. Just going to be like a CPE, some customer's router, and this router 1 might be, it shouldn't be our PE or provider edge because it is an ASPR at the moment, but let's just say the service terminated on there. So the customer CPE connected onto router 1 on Ether 1. Let's start up this other router. No, I don't want to wipe the node. So let's start this up and jump onto router 1 as well, because we do want to set some IP address as well. So let's just duplicate this IP, but this won't be a public IP address now. This is going to be, though we might want to lab that as well, because it does happen that sometimes ISP will transit through each other, and they might even lease out some of their own public IPs to another like smaller service provider, and they kind of like peer to them as if they were an IXP. But we're not going to do that. We're just going to just bring up a normal peer, make this IP address 172. Oh, hang on. 172.16.0.0/3. Alright, so let's just configure these interfaces quickly. Ooh, I probably shouldn't have brought up a version 7 MikroTik, sorry about that. Let me just stop that, delete that, create a new node, MikroTik version 648.1. I'll just call this a CPE. Let's bring in the CPE to ISP1. Start this up. And let's see what's happening here. Admin blank. And we just quickly want to assign an IP address. Okay, bring this up a bit. The system identity set name ISP1 CPE. Let's make the IP address 172.16.0.2/30 on Ether1. And let's just quickly jump onto ISP1. IP address add address 172.16.0.1/30 on interface Ether1. So now what I could potentially do is there's a few ways to approach this type of BGP, but let's use the same AS. So that would be our public AS, and then this would use a private AS. So maybe like AS100 or something. So let's just duplicate that. Give it an AS100. Alright, that looks good. And let's create a BGP here between the customer router and our ISP. So on the CPE, very basic, just jump on the command line, do a routing instance, routing BGP instance, add an instance. The AS is 100, the name, let's just call this data or something, and the router ID, we can make it that WAN address between the customer router and ours, or the ISP, so 172.16.0.2, use that, and then routing BGP peer add, so name, let's call this primary. Our instance is data. Our remote address is 172.16.0.1. Our remote AS is 65.0.0.0. I'm not going to add any filters yet. And on router 1, let's just add another peer to the CPE. So peer to CPE primary, let's call it that. Give it that instance of AS65.0.0.0, make the remote address 172.16.0.2. Our remote AS was 100, and we can just apply this as is. We might send out a default route from the ISP to the CPE, and let's apply that. Let's quickly see what's happening here. We've got a peer, and it's up to our customer. So let's see on the CPE, what am I learning? If I do an IP route print, what routes am I learning? I'm learning all of the other routes. All the routes that I specified on the network tab, and as well as the redistribute connected routes and all that stuff. So two ways we could fix it. Potentially what I would recommend is just on the ISP side, create a routing filter, which you can apply to all your customers essentially for routes that you don't want them to learn. Even though it doesn't matter, those routes are on your network, they'll get to them, but they don't need to see them. We want to keep the routing table pretty simple for them. So we could do a, actually let's do this from the customer router. So we'll do a routing filter, add, the chain will be primary in. Let's do the prefix as 0000/0. Our action is accept, and let's give it a different distance. Let's maybe make that 5, and I can hit enter. If I do a routing BGP peer export, so let's just add this filter to the BGP peer quickly. So routing BGP peer set in filter is primary underscore in for 0. I mean, and then IP route print. That prefix, I'm not getting any changes, but it might be that I just need to do the routing filter disable 0, enable 0. Let's just do another print. So this isn't having any impact. Maybe look at our filters and make some changes. So our prefix is 000/0. So routing filter set. Let's just change the prefix to 0000, and let's make the prefix length 0. Let's see if that has a change. Also no change. Let's just do routing BGP peer. Disable that, routing BGP peer, disable 0, enable 0. IP route print. No, this doesn't have the impact that I'm looking for, because what I could potentially do is routing BGP set routing filter, just remove 0, and let's try something else. Routing BGP filter set, or let's add. I might do this from Winbox, I wonder. Let's see here. So the prefix is definitely correct. Prefix 0000/0. Let's just make it a very basic filter, and the chain was, what was it, primary in, and then routing filter add. We're not going to set any prefix, we just set the action. Oh, that is wrong what I did there. I'm going to just fix that, just by because that action I want to actually accept, but it's fine. Action, this should be discard and the chain should be primary. So if I do routing filter print, we can do routing filter set action as accept for 0. So if I do an IP route print, now I'm not learning any routes. So routing filter export. Oh. Also not what I'm expecting. I'm kind of just expecting those routes to still appear. But it's definitely something with the filter. So routing filter, set prefix. This might be a different way to do it. Let's do it this way. Routing filter. Disable 0 and 1, and if I do an IP route print, I'm still not learning my routes now. Let's just see routing BGP peer. Is the peer, it's still up. Let's just disable, re-enable here. Disable 0, enable 0. And let's see, now I'm learning the routes. So let's do something pretty basic. And we could say something potentially along the lines of routing filter add chain equals primary in, and our prefix will be anything that is not 0000/0. Our action will be discard. And if I do an IP route print now, I can see I am actually learning the correct route still. I'm learning the default route, but I'm not learning all of the other annoying, not annoying routes, but you don't want to have like all these routes just pop up at your CPE, you know, because the CPE doesn't need to see it. And let's just do a routing BGP, routing filter. I still want to fix that filter bit for the 00 route because I want that distance to be 5. So routing filter, add chain is primary in, distance, we're going to make 5, and the prefix should be 000.0/0, and that should be it. And if I do an IP route print, it's not taking effect. Can I stop adding that? And let's just do a routing BGP peer disable 0, enable 0. IP route print. Routing BGP peer resend 0, refresh 0, and routing filter print routing filter disable 3, enable 3. And let me just delete all these additional ones that shouldn't be here anymore. So routing filter, remove. Let's remove 0, 1, 4, 5, 6. Routing filter print. So now anything that is not 00, I'm discarding. IP route print. But my distance is still not what I'm expecting it to be. Let's do this. Tool Ramon set enable, yes. And I'm going to do the same on the ISP1 router, just so I can get onto the CPE through Winbox quickly. So we're going to go there, tool Ramon set enabled, yes. And then I'm going to connect onto Ramon on router 1 and then get to my CPE. Connect. Let's just look at our filters here, maybe switch them up around because that is a thing as well. Let's look at our routes. That's still not what I'm expecting. Disable, let's refresh, resend, disable this, this, and that. And look at our routes again. Routing filters. Let's just set the action to accept. Hang on. The distance isn't set here. Please don't, no, don't tell me. It's two different distances. That doesn't make any sense. Disable, re-enable. Okay, that didn't do anything actually. Let's just do that. BGP actions. There we go. So I set the distance in the matchers, and we just want to set the distance in the actions. There we go. That's such a stupid or silly mistake, because if I go back to the router, I should have actually picked this up already. So IP route, or if I do a routing filter and we do a set, then we can see there is a distance, which is what I just like set, but it wasn't correct because that was the distance for a route that I'm matching, like a route that I'm receiving. And then there should be another distance that we can, so if I do an export here now, route export, there's the set dash distance, so that I didn't update correctly. Okay, cool. So now I'm learning the default route correctly from the CPE. So if I do an IP route print, that's what I'm seeing. So let's just imagine for a second that these routers, let's do this scenario of the interconnect quickly. So I'm here, I'm connecting to Netflix from router 1 on Ether 2, and let's just make it Ether 2 on both sides. And then as strange as it seems, we're going to have another peer running between these two routers. So instead of using the IXP, we'll just connect using the two routers directly. And we're not going to use those public addresses because now we've got some private IPs that we can assign to each other. So let's make this 10.0.0./30 with .1 being router 1, .2 being router 2. So let's add this. And let's see here. IP address print, IP address add, address 10.0.0.1/30 on Ether 2, and the same on router 2. So IP address add address, let's say 10.0.0.2/30 on Ether 2. Then I ping 10.0.0.1. Yes. So routing, let's just add another peer. But this time we're going to use the direct connection that we have between our ISPs instead of through the IXP. So routing BGP peer add name ISP2 interconnect or ISP1 interconnect. Let's make the instance is still AS65001. Remote address is 10.0.0.1 remote AS. Let's just see why is it showing like that. Remote AS is 65000. And I can still set my filters, so out filter, I can still make that ISP 1 out. and my source, update source will be Ether2 now. So IP route print, I'm not going to get anything because I haven't configured the peer on router 1 yet, so let's just do that. Routing BGP peer add name ISP2 interconnect remote address 10.0.0.2 remote AS. This is going to be AS or 65001. Our instance is the AS65000. Our out filter will be still the ISP2 out. And our update source is Ether2. So if I do IP route print or routing BGP peer print, my peer isn't connecting yet. Let's see, I know I can get there, so let's just do routing BGP peer export. And we can also just print the detail. Print, not detail, let's print the status. So you're going to see it's ISP2 IC, the instance is correct, the remote address is correct, remote AS is correct. Out filters, that wouldn't have anything to do with anything. So let's go to router 2, just verify some of the configuration there. So routing BGP peer print status, instance is correct, a remote address is incorrect, it will not work with that. So this is our issue. So routing BGP peer set remote address is 10.0.0.1, and that is for item number 2. So routing BGP peer print. Now all of my peers are established, which is perfect. Am I learning any routes through there? That is the question. So yes, I am learning routes as well, but I'm having some not really issues, but as you can see, I'm learning multiple routes and only specific routes is active. So now the route via the IXP has become the redundant route, whereas the route via the interconnect has become the active route, which is actually pretty good. That's actually kind of what we want, but it just happened to go that way. It's not because we tuned anything with the distances or weight or anything. So what we could do in this instance is on our in filter or on the out filter of ISP1. Let's just do this on the in filter of ISP2 actually. So I know what my chains are here. So routing filter export. I've got a bunch of ISP1, and here's a chain for ISP1 in. Oh, I don't even have any chain for ISP1 in. So let's add a chain for that. So routing filter add chain ISP1 in, and let's just make it not a general thing. So let's say this is via the interconnect. So anything that's coming in via the interconnect, what we want to do is change some of the BGP attributes, and this might be stuff like the weight or the med, or you'll see when we start tuning it and what the effects are. Because currently the routes are being preferred via the interconnect, which is what we want, but I'm going to force it to be the other way now. So here is ISP1 interconnect, and our action will still be accept. But then let's just make it for general. I'm not going to specify any prefixes yet. It's just anything, and then we can do stuff like the. I'm tabbing it, but if we question mark, we can see stuff as well. And then there is the BGP attributes we can make adjustments to. So good ones are the weight and the med. So typically the BGP with the lower med is the one that gets preference, but in the same sense the one with the higher weight is also going to be one that you pick. But I'm just going to tune this med value quickly, and then you can see what the outcome will be. So let's just say action accept, but the BGP med, we're going to make this, let's make it 1000. Actually, let's make it 2000. And let's do a routing filter add chain ISP1 in, and let's call this IXP action accept, and the BGP med we're going to make 1000 for the IXP now. I just need to apply these route filters quickly. So routing filter or routing BGP peer print. We can actually just export quickly. So I know this is 0, 1, 2. So for 0 and 2 we want to make changes. So routing BGP peer set in filter. So the first one is via the IXP, so let's just call this ISP1 in IXP, and that's for 0. And then routing BGP peer set in dash filter ISP1 in via the interconnect, and that is on 2. So if I do an IP route print now, what is the difference? Is there any difference at all even? I'm not really seeing anything. So let's just do routing filter print, routing filter disable 6 and 7 and just re-enable them. Do I see any change now? Still not. Let's just refresh our peers. Peer print routing BGP peer disable 0 and 2 and enable them. This is just so that I can force the connection to come back up. IP route print. Still no actual change. Let's just see IP route print detail. So what I'm specifically looking for is, or are these routes. I'm not seeing that it's applying any of the mids that I'm trying to force. I'm actually going about this the wrong way. So we want to jump back onto ISP1's router, and we can do this on Winbox quickly. And then we'll go to our routing filters, and then on our out filters we just want to add, because I know this out is actually to the IXP, so let's just create a new chain, call this ISP2 out interconnect, and we can set the action to accept, and then our BGP actions will be, let's set this med as 1000, and then for these other routes that we are sending, let's just make this med 2000. So this is actually not going to change anything just yet, but we'll flip the filters around and then you'll see the actual change. So let's just add ISP to IC. You will have an out filter of ISP2 out IC, and then peer to ISP2. I don't need to change anything there. So if I now go on to router 2 and I print the routes in detail, there we go. So this is actually another silly mistake I'm making. We're not going to change like the med that we're receiving from the ISP2 router. We're actually advertising what the med is from the remote end. So ISP1 is telling ISP2 what the weights and med and that stuff is. Now, like I said, the lower med is the one that will win. So in this case, the lower med is the link through the interconnect. But let's just change that by going on to our ISP2 out, and we could just set this mid to something lower. Let's make that 500 and make this other one also 500. And let's just see the routes for 9990. Let's just first see what it was. So 9990 was active via the interconnect, and the redundant path was via the IXP with this mid. So if I look at the routes now, it has swapped around. Now 9990/24 via the IXP has become the active route, and the route via the interconnect has become the backup because it's got a higher med than the route that we're receiving via the IXP. Okay, makes total sense. It does make sense actually. Yeah, that looks fine. Just close this stuff. So what I wonder is, let's create a route on, well, it doesn't need to be a route. Let's just create something like, we don't even need to create anything. So this 172.16.00/30, I'm actually quite curious if I am going to learn that route through other devices. Let's just see on router 2, if I do an IP route print. Do I see that? I do not, but I kind of know why I don't see it, and that is because we forced those routes to be dropped in our route filter. So route filter print, because on ISP1 we're only sending out specific routes. So let's jump on ISP1, and then I'm actually going to make a slight amendment, and we can say, we can copy that, and let's do 172.16.00/30. Let's accept that. I just need to move that up though, because this does kind of work in a sequence as well. So let's put it, okay, now it's actually already moved itself into the correct sequence. Okay, that's fine. And if I go on to ISP2 now, do I see that? No, I don't learn that route, which is correct. It's, even though, let's see, am I redistributing connected routes on ISP1? I don't believe I am. So let's just redistribute connected on ISP1, because I did that on ISP3. And let's see, ISP2, I'm still not learning it, which is a good thing. That's actually something I don't want to learn. Let's just jump here. So router 1. What happens if I specify the network? 172.16.00/30. Apply that there. Let's just make sure we've got that IP there, yes. And now I am learning that's subnet, which is still kind of what I don't particularly want, because I want to see something on router 3. If I do an IP route print, okay, that's actually fine. So router 3 doesn't learn about the route because the filters are dropping it still on router 1. So going to my filters, I'm now accepting that via ISP2 but not ISP3. If I copy this and essentially just change the chain to ISP3 out, and I apply that, then if I look at ISP3 now, I'm also learning the route, which is fine. But again, I don't want to you know, be learning private routes via BGP. What is your question? If I can help, I can try and help, but you'll have to explain what sort of help you need. Like, what is your issue? What is your problem? Let's just close all this stuff. I might actually just disconnect from Winbox. Like, it's so weird. I almost can't believe we've been busy almost 2 hours and it doesn't feel like we've accomplished much. Created like 3 peers with each other, an interconnect and a CPE, and there's still so much more that we can add on this. I'm actually going to end off the lab here, but this is just the BGP lab. I'm not going to call the stream off yet because there's some stuff that I want to Alright, so that is pretty straightforward actually. I mean, it's difficult for me to show this to you on like Eve since this isn't any type of wireless equipment, but I've got some actual smaller router boards that support Wi-Fi. I might be able to bring them out and do a test. But what do you mean with QRT? Because I'm also trying to understand your goal. Is this similar to, let's say, if you're doing your MTCNA, and this is where the trainer like maybe shows you how to set up a wireless bridge? Are you just trying to replicate that? You've got a bunch of WLAN connections to your clients, and you just want to place them all inside a bridge and like give them connectivity via the bridge, or what is your end goal, I think? And let's try and draw this up maybe, because I haven't done a diagram like that in a bit. So let's go to draw.io. We won't do any of this. Let's add some maybe Cisco stuff, because their things look good. All right. Well, let's just say this is a bunch of, actually let's delete that. So what type of equipment are you using for your, oh, nice. All right, so on the bad side, even though I'm sure we can figure it out, radio frequency is also not really like my thing, but this shouldn't have much to do with radio frequency. At the end of the day, it's just you've got an AP bridge, and this bridge is effectively just broadcasting its signal out to all of your WLAN customers, and they'll just be connecting to the bridge on, I don't know, how are you delivering the services? Just like a straight layer 2 wireless connection between the routers from the station to the AP, or are you doing some type of service like triple PoE behind it? Like, how are you getting the customers to connect to the AP first? Because I'm trying to just imagine in my head what you're doing. Let's just add some lines. Actually, we can use the normal line. Now, we could use probably something like Wi-Fi. Look at these dashes. Duplicate that. there. And where is the triple PoE server? Is that running in a data center somewhere, or is that running off of your... Alright, if you have something you can show me. Typically this would just be a station bridge. Okay. But this is quite typical what you'd see. Let me just try and zoom that out a bit. Let's move that there maybe. So that might be your tower or whatever, and then from here we could be running some fiber to the actual data center, where we might have a CCR or something, where you'd have your triple PoE server actually running. So that depends a lot on on the radio frequency, like interference and all that stuff. I mean, if it's a small holding where you've got like almost no interference, it's quite easy to deliver that type of service. But I assume you're just on, let's say, a shared type of tower or something, and you've just got your equipment like patched in there. It's to an extent it's easy to give everybody 6 meg, but guaranteeing it on wireless is always the tricky part. What you could effectively try and do is manage some of the stuff, because you don't want to, like, let's say you sell them a 6 meg service, but you don't apply any type of configuration, and they get whatever the wireless gives them. So they might have like the perfect link, and they can burst almost, not that it will happen, but they're like using a gig of your bandwidth, whatever. So for that type of scenario, you will definitely be looking at some QoS. You definitely want to make sure that you are assigning bandwidth per WLAN interface, and I'd say you would just restrict or limit the amount of bandwidth on that WLAN interface that users can use. I actually want to see if I can bring up that actual MikroTik. So just give me a second. I am just going to switch the camera view quickly, and then I'm going to rummage about in a cupboard to find the MikroTik so that we can play around with the wireless quickly. So I will be right back. Alright, so good news is I found my MikroTiks, but I'm missing their power adapters, so I can't really show this to you in a lab right now. I'll see if I can potentially either create a dedicated stream for it next week. We can look at best practice when it comes to Wi-Fi, but it is also a completely different spectrum to what I'm comfortable with and what I typically work with, because I am really not the best person to speak to when it comes to radio frequency, and I also am not too sure if MikroTik is the way that you want to go when it comes to wireless networking. It works, it's fine, it's good, but I typically see people use other vendors for that. Specifically, maybe like your Ubiquity products or Cambium or stuff like that to deliver point-to-point services or wireless services between locations. I'm just not sure if I can properly replicate what you're experiencing. I mean, it's simple enough to dedicate bandwidth to customers and give them like it's almost like a type of QoS, but with wireless it's very, very tricky, very hard to do because I've seen so many issues from wireless. I think even in the last stream I mentioned it, like people will put up a tower, they'll connect wirelessly to a station, and then the station suddenly just gets a ton of interference because a week from then either somebody else put up their own stuff as well, or a branch grew in front of something, or a bird built a nest inside of the dish. It's really difficult for me to like give you like the perfect best effort stuff, or best, not best effort, best practice. But I will definitely make a stream like next week to power on these MikroTik router boards, and then we can go over all of the station bridge configuration and the station AP configuration, all that stuff. Yeah. Anyways, guys, I wanted to cover something else before I end off the stream. I know that came out of like nowhere. I wanted to see if I could maybe help, but not right now, not how it is with without the power for these devices. So all that I want to do now is actually just go to MikroTik's website, and then I want to just ask a simple question for everybody. Well, all the viewers that's online, what type of certification for MikroTik interests you guys? Like, what do you like doing in MikroTik? What are your goals? Do you, like for you, Club, are you into the, like just the wireless aspect of it, or is it more of the, let's say, the routing and switching and all of the other features that come with router OS? So if you were to do certification through MikroTik, what actually would you like to follow? Because if I do something like the MikroTik certification outline, and let's just see the training programs, there's a ton of different programs with MikroTik that you can pursue, and they each cover a very specific thing. So I think many people that try and get into MikroTik will obviously start with the MTCNA, because that is where you need to begin for anything anyways. But they've also brought out a few interesting additional certifications, namely, well, not recently, but you get like, for you, Club, maybe you'd like to do something like the wireless engineer, which will dive a lot deeper it also depends on the type of services you're providing. So let's say you are I'm guessing a fiber to the home provider, and you've got like a deal with some other ISP that's a bit bigger, maybe maybe like a Telcom or a Bitco or a MFN, or maybe you get some stuff through DFA directly. Are you talking about the certifications club? Because the certifications, it's very dependent on the MikroTik trainers that you go through. So there are quite a few trainers in South Africa, but globally there's many trainers that can offer you all of these certifications. Typically, if you're going to be working with, because I think, since not all the viewers are from South Africa, but for you, a good estimate would be for the MTCNA per person is about 8,000 Rand, which to everybody else that would probably equate close to, I don't know, 400 USD, maybe a little bit more, just by quickly thinking off the top of my head. But it covers like it's a long training schedule, so you'd maybe book it through a trainer, and then typically the MTCNA can run anywhere between 3 to 4 days, where you would be, I don't know how often it happens now, but you would go to the trainer's premises. But with all of the COVID stuff that's happening, it's very difficult to say how many people can be at a training session at any given time, because that depends on the venue, and we all need to, adhere to regulations, obviously, because it's the right thing to do. So MikroTik certification is valid only for 3 years from the moment that it gets issued to you up until the point where it expires. It's only valid 3 years. So here is me with my full awesome name. Oh, I need to say I'm not a robot. Thank you, Google. So this is a nice thing about MikroTik. This will now show you if you have certifications through them and what type of stuff you have. So for me, I've done the MTCNA, MTCRE, and MTCINE, but as I said, they are only valid for 3 years. Here it will also show you when was the issue date. This is one issue that I have with MikroTik though, and it's not so prevalent with the other vendors. Let's say you do your MTCNA and it's valid for 3 years, and 2.5 years from that first time you wrote the exam, you go write your MTCRE. So you could pass your MTCRE, but if your MTCNA expires, or not if, it still expires 6 months later. So with other vendors, what typically happens is if you move up with a new certification, it automatically renews or refreshes the older stuff, because obviously you know what you're doing and you've just passed something more advanced. But with MikroTik, it doesn't quite work that way. You get 3 years, and if your MTCNA expires, even though you've passed your MTCRE, you cannot go write your MTCINE until you've completed your MTCNA again, which is a bit annoying, and you always need to stay on top of the certification and make sure that it doesn't get expired. So for fiber, I would definitely still recommend MikroTik. It's still really good, especially if it's for something like fiber to the home that you're providing. A lot of, I don't want to say small ISPs, but a lot of ISPs make use of MikroTik, and it does come into factor with the cost. If you want to get a Cisco, by all means, if you have the budget, you can go get a Cisco, but it's not necessarily the only way to deliver a service to customers. Cisco is very up in the forefront, but you need to ask yourself, why do you want to get a Cisco? Do you want to get Cisco because everybody uses it? Do you want to get a Cisco because you want to get more into stuff like network automation or SD-WAN? If the question, or if the answer is no, you don't want to get into SD-WAN or automation or stuff like that, then there's really no benefit in getting a very, very pricey piece of tin. If all that you're going to do is be routing some traffic, then a MikroTik is more than capable of doing that. There's also definitely other vendors you could look at. The bigger ISPs, would typically also use Juniper routers for their carrier networks instead of Cisco's, because there's a lot of extra features and functions that just work a lot nicer on Juniper. But MikroTik is fine. You can definitely build your own network off of MikroTik. There's a lot of bigger routers, so you don't need to build your ISP off of a router board. You can use the CCRs, which is the cloud core routers, or you could be really fancy and you could get a CHR, which is essentially the stuff that I've been building on EVNG with these labs. So these are CHRs. They're actual routers. They're just running a trial license for 24 hours, but I can do anything that I want on them, and you can scale them as big as you want. Like this router, for example, it could have been a real production router, and I could have given it something like 4 gig of RAM. I could give it more if I want to. I could make it 10. It depends on what the requirements are. Since this is Eve, I can't really change stuff here, but you could make, if you have 10 gig infrastructure, you could give it 10 gig ports. The Cloud Core Router 1072s, they have SFP Plus ports, so all of the modules that you can put in on the router is 10 gig. And there's also newer routers that's coming out that I think support, it's either 40 or 25 gig. Let's see, the CCR 2004. Let's see, 12 S plus. So that's also 12 SFP plus. That's how much RAM it has. Yeah, QSFP, that's right. Let me just read your question. I have a Mimosa C5C connected from my ISP to my, with a Cat6 cable. So it depends on how far or how the service is delivered. So fiber is obviously faster or better to an extent, but it also supports those bigger throughput speeds. So with something like the QSFP, which is essentially where you get your, it's 40 and 100 gig if I remember correctly, those interfaces you're not going to patch like a Cat6 cable in. You're actually going to need special cable for that. It's also not just a fiber cable that you put in either, but it uses fiber. It's not like just a normal fiber cable. But for you, I mean, if it's Cat6, it depends on your throughput as well, and the latencies that you're currently having. I mean, your ISP connection, what is your average latency and average throughput or bandwidth? How much utilization do you see on your network? Do you see that all of your users are using like 100 megabits per second at any given time, or is it much less? Is it much more? Those are the type of questions you need to ask if you're trying to plan for, I don't want to say building the network, but for future expansion. You know, you need to just think about how much usage there is actually on the network. But is there benefit to fiber? Of course, obviously it will be better, but it's not like going to suddenly change your user's experience to this massive wow, what has changed. It might be like really spot on users that know what's happening could pick it up. Yeah, so fiber, it could probably drop your latency down by a bit more, but maybe like to 1 ms, but you won't really have like this massive, just a big performance jump. But Vinoff, I'm pretty sure it's not like an 18-kilometer Cat6 cable. That's definitely not what it is. But yeah. But what were we talking about? We were talking about certifications. And on that point, with the certifications, there's no like certification to, understand fiber. Like this covers all of the router OS functionality and features and stuff like that, like how to become a better wireless engineer or routing engineer or traffic control engineer. That might actually be something that you want to take in conjunction with the wireless engineer. You could use traffic control engineer with anything really, but that will kind of just help you understand bottlenecking and bandwidth and trends and stuff like that, and how to free up some congestion on the network. And like you said, you maybe wanted to guarantee, even though it's really hard on wireless, like 6 meg per user or per connection. The certified user management engineer, that I don't really see much of a use for. Inter-networking engineer, that's really good. IPv6, I can kind of recommend everybody needs to start looking at that, because we are, even though people's been saying it for decades, but we really are running out of IPv4 addresses. Like, it's an actual issue. Security engineer, that's just more firewall stuff. Switching engineer, so this I'm actually quite interested about, because I've never worked on a MikroTik switch before, but I know that a lot of people actually have questions about how VLANs and switching works on MikroTik. So that's actually something I want to explore in a video later on. I've made a video on VLANs, but to be more in depth about it, because, you know, like, this is actually, if I look at this, it's really going a lot deeper. I've heard Switch OS isn't that nice, to be honest. Most people just load up Router OS on their CRS switches, and then they just manage it like a router with a lot more ports. Yeah, so fast tracking, do you know what fast tracking is before we... Yes, it doesn't make connections better. So essentially what fast tracking does it's bypassing that firewall inspection from occurring. So the traffic is just kind of like sent out of its port without being inspected by the firewall. So it's going to be a bit faster, but that extra fastness, it's like in nanoseconds. And if you are, let's say, if your typical bandwidth usage is like 60 meg for your customers, then I don't think fast tracking will really have that much of an impact for you. Let me start up a router, and then I'll just explain it as it starts up. I might have to just cancel there. Hey Sayed, welcome to the chat and the stream. Yeah, but I'm going to be out of action pretty soon, and it's most likely going to be for a week. I'm not sure if I'm going to be streaming next week. I would still like to, but as I mentioned at the start of the stream, my son is being born tomorrow, so I'm pretty sure I'm going to be very busy for the next week. But after that, when things calm down, then I'm pretty sure I'll be back in the saddle. All right, let's just get onto a MikroTik quickly. And the best way to learn something is obviously to do it yourself, but also to maybe, let's connect there. And then I should see my router 7. So I'm just going to maximize that, and I might zoom in just so that people can see a bit better, because I know Winbox is a bit small if you look at the resolution. Let's just close all these windows. So if we go into the IP firewall, so what we get is a bunch of filter rules, NAT rules, mangles. Before we talk about fast tracking, I want to talk about your connections and connection tracking. So this should already like be a hint, because connection tracking and fast tracking It sounds very similar already. So by default, your router's firewall will track all of its connections. Connection tracking should be enabled if you are wanting to use any type of NATing or any type of firewalling for that matter, because your firewall needs to keep track of all of the connections that's being made as well as the ports, so that it can effectively block or allow connections or NAT the traffic in whatever way that you need to do. What fast tracking does is it's basically when you create a rule that is going to bypass this connection tracking table. So here we get a connection 10.255.2.2, and this looks like some multicast traffic for OSPF. That is actually exactly what it is. Let me see if I can just run a ping quickly. So let's run a ping to 8.8.8.8, and that ping should actually now show up in my connection tracking. So there you see there's a new entry that's come up for 999. No, that's not the correct. There we go. 169.255.0.2 going to 8888 ICMP. So that is the ping that we are sending. So that ping has now been populated into an entry in fast tracking. So what you can imagine is, for this router, there's not a lot of connections going on now, but if you had 1,000 or even more customers making use of your infrastructure to connect to the internet, this table will get filled up quite a lot. I mean, there's going to be a lot happening on the firewall in that instance. But this is now really if you're growing into that big level. So what fast tracking allows us to do is any type of connections that don't require firewall services. So if it doesn't require NAT or it doesn't need to be blocked or anything, then you can enable fast tracking for that connection. So that whenever that connection is made, it doesn't get looked up on this firewall table, and then it's just like, think about it, it's like going onto the highway and you're instantly on the fast lane and you're driving at the quickest speed, instead of having to like go through QoS and all kinds of other stuff. So that's kind of in a nutshell what fast track is. It has its uses, but I wouldn't just say put it on because somebody told you it's going to make your stuff faster. So you could put it on for maybe traffic going to DNS servers, but it's really not just going to. It's like the other thing. It's not just going to, like the fiber thing you mentioned. It's not just going to wow everybody. They're not suddenly going to say, "Wow, the network's really fast today." It's very rare that fast track does that, but it can have that impact if your firewall table starts getting very congested. I hope that kind of answers your question about fast tracking. If you want to see it in action, it's really just a case of adding a filter rule, and we can just set the action to fast track the connection. And I can just say anything going to 8.8.8.8, and then any forward traffic. So any traffic that's forwarded to 8.8.8.8 will now just automatically be fast tracked. I might have to stop the other connection though. But that in essence is what like fast tracking should be doing. It should just make. But it's not going to change your speed from 5 milliseconds to 1 millisecond if you put on fast track. Okay. Let's get back to certifications quickly. I just want to have a look at this MikroTik switch engineer. To an extent, it is safe to use, but I also would recommend testing it first. So you could potentially see where there's the most downtime on the network, and then you could bring it up. It shouldn't just kill your network, but you need to make sure it's not going to have a big service impact. You don't want to just fiddle around with configuration in the middle of the day when, well, I want to say in the middle of the evening, because from what I take it is you've got a lot of maybe home users, and they might have a bigger impact during the evening as opposed to somebody like let's say if you have a lot of businesses connecting through, they would get that impact mostly during the day. But it's so weird now with work from home, you know. It's hard to say when people are the most busy. But put it on, test it first. If you see it's causing issues, you can disable it. Just make sure you specify exactly what you want to fast track. Don't just make it like a blanket rule, say fast track everything, because then you are going to break things and people are going to get a bit mad. Are there many jobs in MikroTik? So that is a very good question as well, and I'd like to think there is job opportunities for people that are certified in MikroTik. Reason being, a lot of ISPs make use of MikroTik devices as CPEs, which is customer premises equipment. So they typically put down a MikroTik router because it has all of the enterprise routing functionality that you want in a router, at a tenth of the price of any other competing router. So it can do BGP, and you don't need to pay out of your nose to get one of these little boxes. The only downside is that you hear people always compare it to the Swiss Army knife. So it does really well what it can do. So it does BGP perfectly fine, even though it's currently only on one processor. That they're changing to be multi-process in version 7, but the BGP works fine. OSPF works fine. Any of your normal routing things that you want to do on a router works perfectly fine on a MikroTik. The only downside is it's also limited, as where you'll see, and I discussed this a bit earlier in the stream. So vendors like Cisco or Juniper, they're looking more at cloud-based computing. So they're looking at software-defined networking, they're looking at automation, they're looking at stuff like SD-WAN, which is software-defined WAN, and MikroTik doesn't have any of that. So if that's what you're wanting, then sadly MikroTik can't offer that for you. But if you're looking for a router that you're going to put down at a site, you want to configure BGP for failover, do some QoS, add different VLANs, and set stuff up on a firewall, the MikroTik works perfectly fine for it, and that's why a lot of ISPs use MikroTiks for that purpose. So I do think there is work for people that have MikroTik certifications. It's not like it's a it's not like a worthless certification. I think what a lot of people misunderstand with MikroTik is they associate it automatically with wireless for some reason. They think MikroTik and they think wireless, and it's sad because MikroTik, its strongest point is its routing. Like that is the actual strong point for MikroTik, and people will get a MikroTik certification because they want, yeah, that's also true, the no licensing cost. That's actually so strange to me that sometimes it is cheaper for you to buy new tin from a vendor. So I've seen this happen. You get a Cisco, you get a license for it, and then instead of renewing the license, you buy a completely new Cisco because you get some special deal and it's cheaper for you than just to relicense the tin. It's such a strange concept to me, but it happens. So yeah, that's not a thing with MikroTik. MikroTik, you buy the hardware, and there's actually like license levels. MikroTik license levels. Levels. So here you can see what the license levels are. So this routers that I keep spinning up, yeah, it is excess. It is definitely that's actually what it is. But these routers that I keep spinning up on EVNG, they're just trial licenses. Like they can do everything for 24 hours, even though they technically do it for more. If you buy a physical MikroTik, like a 951, like these little boys that I brought out, which I don't have the power for now, they are license level 3. And then if you get like your CCRs and your other stuff, they'll be a higher license level, and you can do way more stuff on them. Alright, interesting. Let's just close that. Oh, there we go. Plus 2XS. I'm just going to mute that. I just want to see. Oh, I'm curious about those ports. Because those are all 10 gig. What is XS? Let me just look at that. CCR 2004. SFP 28. Right, so this is actually a local vendor in South Africa as well. And that's actually quite a cheap price for a cloud core router. It's actually really cheap. Can I zoom in a bit more? I'm pretty sure those are the 28s. What are these specs? 25 gig. Okay. But I think this SFP 28 still runs on normal. Yeah, it's like normal. Yeah, you're right. It is copper, that is. Well, it looks like copper. Or is that SFP port? No, it's SFP port. So it could be fiber as well. But that's decent. I mean, that's actually for a, think about it. I want to quickly look at Cisco. Actually, look at this. Juniper MX80. This is like, we could even go MX40. This is like a very small, this is considered a, well, not very small. The MX5 is probably your smallest carrier grade Juniper. Let's check MX5, like the smallest Juniper router that you can get. Look at this. Look at this. It's like 30,000 USD for a Juniper MX5, and look at what it does. It's got 4, well, that's the upgrade kit, but it's got 4 10 gig ports essentially. Like that's what the MX5 has. And if we compare that to this MikroTik that has, it seems like 12 SFP plus ports, so that's 120 gig total, obviously, but that's 12 10 gig ports, and then 2 25 gig ports. The 25 gig ports you can use for aggregation, either to an upstream or to your switches, and you could potentially bring like interconnects into the actual SFPs, or you could also just uplink those to some access switches. I mean, this is such a way better deal than than getting that MX5, in my opinion. I mean, the MX5, like I said, it's got the software-defined stuff as well. Let me just see, can I get the CCR 2004 USD? How much is that in USD? Come on, that's a no-brainer. Really, that's a no-brainer. So you could either pay 550 USD, or you can pay 30,000 USD almost, and then you'll get less throughput. I'm not like bad mouthing Juniper. I love Juniper, but I'm just throwing that out for perception. Like It's like when you are a youngster. Man, I feel like I'm getting old when I say stuff like that. But when when I was young and I was, let's say, in school, then you would always um, try to fit in with the crowd by buying or getting your parents to buy you the clothes that was a specific brand or a name, instead of just like wearing something that's cheaper and it's exactly the same stuff. But yeah, we can go to MikroTik.com. So that's the issue I have with brands as well. Like a lot of times people just buy um, brands instead of looking and doing hardware comparisons. Uh, can I, if I say buy, let's just go to the hardware. Let's find the CCR. I've heard bad things about this RB4011 though. We've set a few of them up, but I haven't heard good things about them. There we go. Alright, so let's say 595. So that is such a big cost saving. Come on. That's not even... This I have a few of in production. So the 1072s. So let's say this is what I'm using for my network. But if you look at the 2004, it's still way more throughput you get, but this is like such a powerful device as well. But again, it's up to you guys. Do research. Don't just go for... Don't just become invested in Cisco because you just see it everywhere, because they push for the marketing. It's always advertised everywhere. This is what you need to do. It's the same reason network engineers will tend to try and get a Cisco CCNA network qualification, because this is all that they hear. That they're told you need to get this to get a job. Meanwhile, you can go do the Juniper JNCIA, which does exactly the same, if not more, than the Cisco certification. Or you can even get the MikroTik MTCNA, even though I feel like it's less valuable than the two alternates. There's still basics that you learn. There's still network engineering stuff that you learn. So it's not like if you don't get a CCNA, you're not a network engineer. You can go get the MTCNA and you are still a network engineer. Networking as a whole works as a standard, unless you work on proprietary software, meaning things that are only available on that vendor's equipment. It all works the same. If I'm assigning an IP address on a Juniper, a Cisco, a MikroTik, a Huawei, an HP, a whatever, it's basically the same process. The commands might look a little different, but if you know what you're wanting to do, you'll figure it out, I promise you. And that's why I suggest just go get a network certification. Go get the MTCNA, or go get Juniper or Cisco or Huawei even. I've gotten the HCIA or something, like the Huawei routing and switching, and it was really not that bad. Lots of stuff that Huawei is like pushing forward. They actually do segment routing, which is really impressive. That's great, damn son. So I also use MikroTik at home, and I use it like everywhere, to be honest, like at customers, at my core network. So I could definitely say it's a good router, but it has its problems obviously. But all the vendors has their own issues. I can assure you that I've had issues with Cisco's and Junipers as well. Um, the only problem that I have with MikroTik sometimes is if you run into a problem, it sometimes feels like I don't want to say a free for all, because you can log a ticket with their support, and the support guys are very, very helpful. But sometimes they don't even know themselves what the issue is, and it feels like you're all kind of like troubleshooting, trying to find and fix the issue, which is a very rare thing, but it's not similar to like if you have an issue with Cisco or Juniper, it will go through like a proper process. There's like this fancy ticketing system. Even though I appreciate MikroTik being more open, it feels more like a family because you're discussing directly with somebody and you guys are getting to the issue together. Whereas it's a very formal process with Cisco and Juniper, but in the corporate or business world, that's sometimes a necessity as well, because you need to know that there's a process, where the ticket is, how it's being escalated, how it's being handled, all that stuff. Whereas it doesn't feel that way with MikroTik. You send the email to the support, and then you're just like emailing each other up and down. You know, unless they've added a ticketing system, which I've never used, but that's one thing. Cool. So we've discussed some more stuff about certifications, and I'm just going to close all of these tabs. And then before I actually end off the stream, I just want to see if there's anybody else that wants to ask or know anything, or are you curious about anything about MikroTik or about network engineering in general, and then let me see if I can maybe answer somebody. Maybe I can, maybe I can't. Because I am probably going to end the stream off relatively soon, since I also need to get some sleep in and then be wide awake for my son's birth. Let's just leave that, close this stuff. Securing MikroTik router. Okay, so I've made a few videos about securing the router, but there's a lot of good tips out there on the type of stuff that you can do to make sure that your router is secure. Do I still have these routers open? Yes, I do. So let's just go into Winbox and look at a few like good practices that you can put onto your routers. This includes your CPEs or your provider edge equipment, just to make sure. I'm not going to say you're not going to get hacked, but you need to make sure, as long as you do this, the chances of that happening is really low. And this really comes into play with stuff like our IP services. Typically what you see at your IP services, this API stuff, if you're not using it, turn it off. FTP, turn it off if you don't use it. SSH, do you use it? Well, I use it. I'll change the port, make it something else, 2202 or 222 or something, just so that it's a bit more difficult for people when they run port scans against your network, so that they don't just immediately get in. And here's a nice thing, this available from, and this works in conjunction with your firewall. This will say SSH is only available, I can only SSH from specific ranges. So in this case 192.168.74.0/24, and we can drop that down and make it more ranges. So typically you maybe want to you maybe want to make this your public IP ranges, or maybe your management ranges, so that only those IPs can access the router on its management ports. One thing that people also don't know is you can change the Winbox port. So let me actually jump onto that IXP router, and then I can show you more clearly, because we're going to have to connect to an IP and not via ROM. So this IXP router, I'm just going to connect, and then from here, if I go to my IP services, let's disable the API stuff again, FTP, and then Winbox, I can change this port to something else. So I could make this 8200. I'm not saying you need to do that, you can make it anything else you want. No, those ports are normally not just open to the LAN, it's open to everything. That's the thing about routers that people a lot of the times misunderstand. routers by default allow everything. Firewalls, which a MikroTik router is not, it does firewalling, but a firewall by default has what we call an implicit deny rule that just drops all the traffic, whereas the MikroTik is just kind of allowing everything. So that's why we need to specify these things. So that's why I just want to show a best practice thing. Let's just change the Winbox port, and let's make sure that the allowed from address is 192.168.74.0/24. So if I Winbox now, if I try and Winbox, it's failing. But what I could do, and this is what people don't know, is you can add the ports just like on your browser, and I can make it 8200. And if I connect now, I'm back on the router. So if I was a hacker, I would be scratching my head because I wouldn't be able to get in. Okay, so let's just go to your example quickly. So if we go to the IP services, that green means anywhere. So it would be accessible from the WAN as well. So if that MikroTik, it might be that you had something specified on the firewall rules, which I'll show you in a second. But yes, what I'm doing now you can essentially do from the firewall as well. I would actually recommend doing both to be extra careful, because you don't want to leave yourself open to any type of attack. No, I wouldn't say you're doing anything wrong. Right, so this just basically covers the IP services, which is very simple and straightforward, because these are just the services running on the router, which we can limit to specific hosts, and we saw we can change the ports. If you want to, you can add stuff like certificates, but that only applies to specific things like this www-ssl. Other things that you need to also make sure you secure, and this is what you joked about earlier. If I go to my system and my users, please don't leave your username admin and your password blank if you install any new router. You're going to definitely get hacked because it's admin blank. So if they can access the router, if Telnet or SSH is open and your username is just admin and your password is just blank, the likelihood of them gaining access to your device is very high. So just change the password, make it something secure. Don't just make it password 123, stuff, your birthday. Don't make it stuff like that. Typically what I might recommend is going to, like, let's say Google keygen. No, I don't want, there we go. Is that what I want? No. Don't do that. Google IPsec key cloud.google.com. So this might be something that you could use to generate a password if you want a really secure password. People ain't going to be hacking this really soon. But you could figure out your own password that you want to make it. Let's maybe just go into a plain notepad, and I might make my password something like the network something like that. You know, it doesn't have to be like something that's really long or anything. You could make it shorter, just as long as it has special characters, some uppercase, lowercase keys. It will be a fine password. And then similarly to the IP services, you see here we get our allowed addresses. So always try and specify your allowed addresses. The more you crack down on this, the less likely you're going to get, again, abused. And now I'm going to change this password back to blank, which is silly. But let's just look at the actual IP firewall. So on the IP firewall, we got firewall rules, which we can specify for traffic that happens to the router. So by default, if you're just installing a router board and you don't remove the default config, it has some basic firewall input rules to block certain things. But what you could do is input is essentially rules that relate to traffic that is coming into the router itself. That's not coming from anywhere from the outside. It's not passing through the router. It's not trying to get to a host sitting behind the router. It's not trying to get to the internet. It's the router. That is what input is, traffic coming to the router, to one of the IPs or interfaces of the router. So we can say anything coming in. And what you could do is, if you want to be like really hard on it, let's say we know that we know Ether 10 is the interface where our internet comes in, or even our triple PoE interface. If there was one, we could select that. And then what we could do is we could specify the protocols. So here we might see something like the TCP, and we can specify what the port is. So 22. So here I'm saying anything coming into the router on TCP 22 on port 10, I want to drop, and you can apply that. So that is a firewall rule that is now taking care of that business. So I could now try and SSH again to this router. Let me just see that this doesn't have anything in the services. 22, okay, that's fine. So we're going to say anything on 22 to 192.168.74.135. Can I open that? Well, I'm able to connect. Let's just go back to the IXP. Let's look it off. Oh, but I'm being silly. Why am I being silly? Because I used Ether 10 as an example. Let's just see where is the IP address bound on Ether 1. So what I'm going to do is on the firewall, we're just going to change that port to Ether 1. So that is my WAN port. And if I do the same test again, so go to PuTTY, and I'm connecting to that on 22, I'm getting a big fat no sir, I'm not letting you in. Yeah, so that's probably what you're seeing, Siberia. The default configuration has a bunch of input rules like this. This is why even on like Ether 1 you can't connect via Winbox and why you need to like connect on Ether 2 when you do the first time setup. I'm not sure if that's happened with you, but yes. So if you look at your router's firewall configuration, you might see a bunch of different rules like this one that just deny certain traffic. Because here I can deny telnet. This is also where you can potentially, if you find that you can see somebody's trying to DDoS or brute force you, if you see it's forward or input, you could also just drop their traffic. You can specify their IP pool, and you could just say, it's good to specify your interfaces and such, but if you know it's just that IP range and it's public, then you could leave it like that, and you could also drop their traffic. Log is also useful, so that it actually writes a log of the event. Let's quickly do this. So we're going to say anything coming from 192.168.74.0/24 we're going to drop. And I'm probably going to lose connectivity now. Which is normal. Yes, that is correct. That is correct. So on that default config, that is fine. But that really only applies to router boards. For your cloud core routers and your CHRs, there's no like default configuration, so you need to make sure you're always on top of what you're doing. I'm just quickly going to disable that rule that I made. So let's go back in here. But as you see, the rule is working. Now I can't get onto that router anymore. But that's why firewalls are dangerous. If this was a live environment, I might have had to make some other changes, even though I think I can Mac telnet to it. Or Mac Winbox even. You could do that. MikroTik QoS works fine. MikroTik QoS is decent. There's different types of QoS that you can implement. I mean, you get your very basic, simple queues, which isn't it's not really QoS in my opinion, but it can guarantee types of bandwidth, and you can make sure that certain services get certain amounts of bandwidth. It's fine for that. But you can use the PCQ and stuff like that for more in-depth QoS that you might see with other vendors, where you would assign essentially a numerical value of the type of service that's being delivered. I think the lower the value, am I mixing it up now? But I think the lower the value, the more best effort it is. So if it's set to 0, it's pretty much best effort, and then the higher up you move, the higher priority the packets will gain. I think it's up to like 7 or 8, and then that's like pretty normal QoS you might see on something like a Cisco. But you can do that on MikroTik as well. MikroTik is totally fine for QoS. IP firewall rule, IP firewall. Vulture print, IP firewall vulture, and then we're just going to remove 2 because that is what is now breaking all of my connectivity. And if I climb back onto Winbox, can I connect? I can't because I think I've made that port 8000. There we go. Let's see here. Okay, that looks fine. Let's just quickly look at our queues. There we go. So here in our queue trees, we can specify stuff like our priorities and whatnot. But the QoS works fine, totally. I think it's been in beta for a very long time. If I'm not mistaken, like a good few years. So I think version 7 might still be in beta even this year. Look, I'm also hopeful. I also want it to come out. Reason being is there is really a ton of cool and nice features that it's not even just about the WireGuard. I think I've made a video on YouTube about how to configure WireGuard on version 7, and I enjoyed it. But it's not specifically the WireGuard I'm so interested about. I just want to open up my MikroTik folder here. Let's just get into the let's open up these beta routers. So these are all running version 7, beta 5, which was the latest version. And then I just quickly want to look at the stuff that's really interesting to me for the future of MikroTik. But I actually wish that MikroTik would bring out a few different things as opposed to what they currently have. And if they had to do that, it will increase the time of them releasing the software version. Because WireGuard is nice, but how does WireGuard compete against the likes of SD-WAN? Like I mentioned this earlier, and it's a no-brainer. You're probably going to still try and get SD-WAN as opposed to a device that can just do WireGuard. But this I like seeing, and this I want to make a lab on as well, and that is the VXLAN on MikroTik. I've not done that before, Boston. I could potentially do that because if you think about WireGuard, it's typically just a yeah. Essentially, WireGuard is a alternative to IPsec, and I can agree. MikroTik's IPsec is really not nice to set up. It feels really awkward, especially when it comes to the firewall policies that you're adding. Um, so it is a good alternative to IPsec, and it works technically better. But I would rather prefer getting SD-WAN on a MikroTik and having an actual firewall create my IPsec tunnels than get WireGuard. Even though I'm very happy with WireGuard, it's just that's how I see it from a carrier perspective, at least. There's also other services I might really have liked to see in version 7 rather, which is maybe something like IS-IS. So I'm not sure if you guys are aware what that is, but IS-IS is kind of like OSPF, but it's better. And one of the big features for it is it's running at layer 2. So it doesn't have to do all of this broadcasting and whatnot. It's layer 2 protocol, and it's learning all of the routes. It works very nice with MPLS, whereas I don't see that coming to MikroTik, but it's on your Cisco's and your Junipers. It's so strange because IS-IS is technically the best IGP that you can get, but only like really big carriers use it. Small networks typically just use OSPF for some reason, and it's the same like debate about OSI versus TCP/IP. Like OSI was technically better, superior, but just more people use TCP, and it kind of like faded out. So this is where we are. I would love seeing IS-IS on MikroTik though, but I don't think it's coming. But I do like how the BGP is working. I have set up some BGP stuff using router OSV7, and it's pretty cool. It's pretty fun. What else is new besides the WireGuard and the VXLAN and the BGP that's been changed? I don't specifically see anything else. Alright. Okay guys, I'm actually seeing I've streamed over 3 hours now, so I'm actually going to call it an evening. Boshan, I hope I helped you with some of the security questions. There's definitely more we can go into. Before I call it off though, there's something that I have been working on that I want to give not like a show, but I will probably ask some people if they maybe want to, I don't want to say get free labs, but I've been working on almost like an MTCNA thingy where, think of this as a study guide, but I'm creating lab files where there's basically like a pre-config, which is before any changes are applied, and then there's a like after config so that you can like reference and see what the differences are. And then I want to give people like tasks and whatnot to try and help more people learn, you know, MTCNA or MikroTik in general, because I really love MikroTik. Let me just open up this document on Google Docs I've been working on. So it's nothing too special, but this will also come with like a reference guide, you know, just to show people like more information on how to do certain things, how to log in, all of the cool stuff. And I'd probably like to get this all finished in the next 2 weeks. So I'm not sure, is that something people would like to see? Maybe like a MTCNA complete guide with actual labs where you are actually configuring things. I think that could be fun. but that's just my opinion right now. I'll see how things go after I've finished creating all of the labs and I've shared it with a few, let's say, test people, just to see how well it takes and how good it is. Anyways, guys, that's all that I wanted to cover tonight. I'd like to thank everybody for watching the stream, for tuning in. There's been some ups and downs in the stream, but I enjoyed it immensely. And thank you guys for watching. I'll catch you in the next stream. I might not be streaming next week, but the week after I'll definitely be back. And I wish you all the best. Have a great day, evening, whatever time it is, and I'll see you guys again soon.